we collect data from how humans do the tasks. We are then able to teach machines how to do those tasks.
It actually gets way crazier when you think about the Optimus robot, which is really a humanoid robot that is intended to be able to do anything you want it to do.
You probably didn't notice, but the future just became affordable. While tech Twitter debated whether AI would take everyone's jobs, something more tangible was happening in factories across 2 continents. Machines that once cost $500,000 and couldn't walk across a room without collapsing, they now cost less than a used Honda Civic, and they work. This isn't about incremental progress. This is about crossing a threshold that transforms experimental technology into something your neighbor might actually buy. The price point that breaks everything. Let's talk about what $6,000 actually means. That's the current price for a humanoid robot that can do backflips, not a research prototype, not a university project that barely functions. A commercial product you can order right now. For context, 10 years ago at the DARPA Robotics Challenge, the competing machines cost around $500,000 each. They moved like they were perpetually drunk. Most couldn't complete basic tasks without human intervention every few minutes. The economic transformation here is almost violent in its speed. We've seen 98% cost reduction in a decade while simultaneously achieving massive capability improvements. That's not normal. That's not how technology usually progresses, even in fast-moving fields. When functional humanoid robots reach $2,000 and multiple companies claim they're close, the market explodes. That's laptop money. That's convince your spouse this is worth it money. That's college students pool resources and buy one money. Why this happened now? The timing isn't coincidental. 3 separate technology curves intersected simultaneously, and that intersection created something new. First, vision systems became genuinely useful. Robots can now see and understand their environment with reliability that was science fiction 5 years ago. They recognize objects they've never encountered. They understand spatial relationships. They map 3D environments in real time. Second, language understanding crossed the threshold from impressive demo to actually works. Robots now understand "I'm thirsty" means retrieving a beverage, not just processing words. Context matters, intent matters, and the AI finally gets it. Third, the manufacturing infrastructure matured. China spent 20 years becoming the world's factory for electronics, batteries, motors, sensors, everything robots need. When demand appeared, supply chains were already in place. That convergence created possibility where none existed before. 2 countries, 2 philosophies. Here's where it gets interesting. America and China are approaching this opportunity from completely opposite directions, and both strategies might work. The American bet: build the smartest robots possible, create machines with exceptional capability, deep intelligence, adaptive learning, then figure out how to manufacture them affordably. Figures robots use custom motors, 16 degree of freedom hands, 6 cameras, dual GPU systems processing 200 operations per second. Boston Dynamics switched Atlas to electric actuators and developed unified AI models controlling both walking and manipulation simultaneously, something that seemed impossible 2 years ago. The assumption underlying this approach: superior capability justifies higher initial costs. Customers will pay premiums for robots that genuinely work well. Quality compounds through network effects as smarter robots collect better data, improving faster than competitors. The Chinese bet: build adequate robots immediately, get them into markets fast, iterate quickly, manufacture at scale, let state subsidies absorb early losses. Beijing launched a $1.4 billion robotics fund. Shanghai added another $1.4 billion specifically for humanoid robots. That's nearly $3 billion in direct government support before counting provincial programs and tax incentives. Chinese manufacturers filed 5,688 robot patents in 5 years compared to America's 1,483. They're not trying to build the absolute best robot. They're trying to build good enough robots everywhere simultaneously. Unitree's G1 walks, runs, jumps, climbs stairs, does martial arts demonstrations, and costs dramatically less than American alternatives. Processing runs on commercial NVIDIA modules. The design philosophy is pragmatic. Use existing components, optimize for manufacturing, ship volume.
Humanoid robots will be the biggest product ever. The demand will be insatiable.
You've said that.
Everyone's going to want one.
What good enough actually means: Here's the thing people miss about technology races. Good enough usually wins. The best product doesn't always capture the market. The first adequately functional product at the right price point often does. VHS versus Betamax, Windows versus Mac, Android versus iOS in developing markets. If Chinese manufacturers flood global markets with $3,000 robots that successfully complete 80% of household tasks, while American companies sell $30,000 robots that complete 95% of tasks, which future seems more likely? This is especially true because robots improve through data. More robots deployed means more operational data collected. More data means faster improvement. Scale creates its own advantages independent of initial quality. The Google wildcard. Then there's Google playing a completely different game. Their Gemini AI can be plugged into robot hardware and it just works with minimal additional training. Carolina Parada, head of robotics at Google DeepMind, basically said the quiet part loud. A lot of what you saw today, we didn't even work that hard to get. It just flowed out. Meaning improvements to Gemini for general purposes automatically make robots smarter without separate development efforts. As the foundation model gets better at understanding the world, robots get better at operating in the world. That's a different kind of advantage, not manufacturing scale, not individual robot capability, but transferable intelligence that improves across every application simultaneously. If this approach works, if general AI really does directly translate to robotic capability, then whoever builds the best foundation models controls robotics by default. The applications nobody's talking about. Everyone focuses on domestic applications, robots folding laundry, loading dishwashers, obvious stuff. But think bigger. Elder care. Japan has a demographic crisis with insufficient caregivers for its aging population. Robots that help seniors with mobility, medication reminders, companionship, that's not a luxury market. That's essential infrastructure. Dangerous work, mining, construction, disaster response, hazmat situations, jobs where human presence creates genuine risk. Robots don't need OSHA regulations. 24/7 operations. BMW already runs humanoid robots on 24-hour factory shifts. They don't take breaks, don't need benefits, don't quit unexpectedly. The economics are obvious. Remote locations, Antarctic research stations, deep-sea facilities, space applications, anywhere human presence is expensive or impossible. The domestic robot market is huge, but it's not the only market. It's possibly not even the largest market. What happens next? We're approaching multiple inflection points simultaneously. When humanoid robots reach $2,000, consumer adoption accelerates dramatically. When they reach $1,000, they become impulse purchases for upper middle class households. When deployed robots exceed 1 million units globally, data advantages become self-reinforcing. Leaders pull ahead faster. When robots successfully complete 90% of requested household tasks without intervention, they cross from interesting gadget to actually useful appliance. All three thresholds seem achievable within 36 months. The competition that just concluded in Beijing, the Humanoid Robot Olympics, received almost no international attention. 16 nations competed. Robots played soccer, ran track, performed martial arts. Most people have no idea it happened. That's the story here. The revolution occurred quietly. No dramatic announcements, no Steve Jobs keynote moments, just steady progress compounding until suddenly the impossible became commercially available. The real question. It's not whether humanoid robots will become commonplace. That question is answered. They will. The real question is who builds the infrastructure that defines this industry for the next 50 years? Does America's focus on intelligence and capability create insurmountable advantages through superior performance? Or does China's focus on scale and cost create insurmountable advantages through ubiquitous deployment? Maybe both strategies succeed in different markets. Premium robots for wealthy countries, affordable robots for everyone else. Or maybe one approach proves decisively superior and the other becomes a historical footnote about strategies that didn't scale. What's certain is that the decision point is happening now in 2025, while most people aren't paying attention. The robot revolution didn't announce itself. It simply arrived quietly at a price point most people can almost afford, and that changes everything.